division algorithm. So division algorithm for a polynomial. All right. So if we know, if a quadratic polynomial, if we know both the zeros of the polynomial, we can get the polynomial. If it is a quadratic, if we know all the three, then we can get the polynomial like x minus alpha into x minus beta into x minus gamma. What if you know only one zero of the polynomial? How to find the other two, right? So that's where this division algorithm will help. So let's look at one example. And I will explain step by step, like how this algorithm will work. What are the different steps involved to do a division for a polynomial when we know any one of the zeros of the polynomial. For example, let's consider this. Let's consider the polynomial. First, we'll do with a quadratic polynomial, and then we'll move to a cubic polynomial. So the first polynomial, the quadratic polynomial, is p of x equal to 2x square plus 3x plus 1, and they are saying minus 2 is one of the zeros. So they'll ask like this is a polynomial 2x square plus 3x plus 1, and minus 2 is the root of the, or minus 2 is the zero of the polynomial. Then divide p of x with x plus 2, right? Now, so how we do this? So it is just like any division we do, right? If it is like a 625 by 25, how we will do? We'll have a divisor, we'll get quotient and remainder, right? For example, if you want to divide 625 with 25, so what we will do? 25 2's 50, and then I get 12 here, and then I'll bring this down. So 25 5's, 125 and 0. This is how we do the division. And similarly, we can do the similar division for polynomials also. I'll explain you. So here, what is this? This is a divisor, and this is quotient, right? This is divisor, this is quotient, and this is remainder, right? So we also know that, right? What is dividend? Dividend equal to divisor into quotient plus remainder. This you would have learned in your primary, right? So here 625 we can get using the divisor is 25 into the quotient is 25 plus the remainder is 0. So this is how you will get. So same division algorithm, the division principle applies to the polynomials also. Okay, so let's look at how to do this. Now, the first step is, first let's write that polynomial 2x squared plus 3x plus 1. With x plus 2 we need to divide. Same thing. 625 I wanted to divide with 25. Now 25 2 times it goes. The closest is to 50, right? So how I got that 2? Because I know the 25th multiples. So 25 ones is 25, 25 twos is 50, 25 threes is 75. So I took the closest value, which is 2 times. But here, how can you do for a polynomial? That we can't do. So what you need to do is first take this value, that is 2x squared, and take the first value of your divisor, that is divide these two. So here it is 2x squared, here it is x. So I am dividing these two. So x gets squared. So the value here remains is 2x. So that means this will be your multiplier. Understand? Like how I got 2 there, here I am getting to 2x. 2x should be my multiplier to solve this polynomial. So how I am getting that? The first term in the polynomial needs to be divided with the first term in the divisor, that is x. So if I do that, I'm getting the value 2x. So why I am taking that, I'll tell you here. So 2x into x, what it becomes? So now x plus 2, you need to multiply with 2x and put the value here. So x into 2x is 2x squared. And then plus 2 into 2x is plus 4x. Now what we will do in the division, we will subtract it, right? So if I want to subtract, the signs will change here. So plus 2x square minus 2x square gets cut. So for that reason, I got 2x there because I want to get the exact term. How I will get whatever is not having in that first term of the divisor. So here it is 2x square, there it is x. So if I divide, I'll get the multiplier 2x. So 2x into x is exactly, we'll get the same term. So that's the hint. So how to get to the divisor. Now, this is 3x minus 4x. So that means minus x. And then I'll bring down that next value, that is plus 1. Same like how we did, how we brought this 5. Now, so this is minus x plus 1. Now, you see here. So now this becomes your polynomial, this value and this value. So here it is minus x. How to get the next multiplier? Minus x by x. So x gets cut, so it is minus 1. So your next multiplier will be minus 1. Then your quotient becomes 2x minus 1. So now with minus 1 you multiply. X into minus 1 is minus x. And then plus 2 1 minus 1 is minus 2. Now again subtracting. So the signs will get reverse. You know this, right? So x gets squared and here plus 1 and plus 2. So this becomes plus 3. So this is reminder because you can reduce the polynomial until the divisor coefficient and the polynomial coefficients are equal. So here 3, there is no x term. So you cannot further divide it. So that will be your reminder. So now if you see here, what is your divisor, right? So what is your divisor is x plus 2. What is your quotient? 2x minus 1 plus reminder. That's what our dividend, right? So our dividend is what? P of x. So our P of x can be obtained by multiplying the divisor into quotient plus reminder. So let's see if we get the same value or not. If we get the same value, then it proves that our division is correct. Now, x into 2x square and x into minus 1 is minus x, and then plus 2 into 2x is plus 4x, and then plus 2 minus 1 is minus 2 plus 3. Now 2x square minus x plus 4x is plus 3x, minus 2 plus 3 is plus 1. So this is P of x. Is it matching with our quadratic polynomial we took? That is our dividend, right? So this is the algorithm, or this is the division algorithm, how we can divide a polynomial if we know any one of the factors or zeros of the polynomial. Hope you understood now, right? So what I have done, there are step by step. It is exactly same as any numerical division. And here finding the multiplier is little tricky, and I have given the hint there. So first you write the polynomial here, right? Polynomial, like in our case it was 625, and then the factor. The factor, one of the factors was the zeros. One of the zeros of this polynomial was minus 2. So this is x plus 2 is the factor. So x plus 2 with x plus 2 we are doing. Now here how to get the multiplier is take the first term in the polynomial and the first term in the divisor, divide those two to find the multiplier. So 2x square by x, we got 2x. So I put 2x there, and then I multiply x plus 2 with 2x, and I'll write the values here, and then you subtract. So the first term gets cancelled, and then the second term, whatever the value remaining, you put here, and then bring down the next value, how we do in the divisions. Now this became minus x plus 1. So you still have the x term, so you can divide it further. So minus x by x. Now this is your polynomial. With that, you divide the first term, you will get the multiplier there. So minus 1. So just add there minus 1. and then multiply x plus 2 with minus 1, you will get the value. This time xx gets cut, so you got the constant value here. Now you cannot further divide this because there is no x term. So you can stop, and that will be your remainder. And we have validated. How we have validated? Dividend equal to divisor into quotient plus remainder. That we have been doing that for all the divisions since you are primary. So dividend equal to, in our case, dividend is p of x, that equal to the divisor, that is x plus 2, and the quotient. The quotient we got is 2x minus 1 plus remainder. So if we multiply and solve that, we got our quadratic polynomial, our divisor, our dividend. Now, the same thing we can do for a cubic polynomial. Let's look at that so that you are a bit confident when we get to the cubic polynomials. So let me take any one cubic polynomial. In this case, I just noted down p of x as x cube minus 3x square plus 5x minus 3. Can you divide this with x square minus 2? See, earlier I took a quadratic polynomial and one factor. But here, a cubic polynomial, you need to divide with a quadratic polynomial. Okay? So p of x, you need to divide with x square minus 2. Okay. So by looking at the cubes or squares, don't get panic. What you need to just remember is it is like any other division. Just follow our thumb rules, right? So what is our thumb rule? First write the polynomial here. So x cube minus 3x square plus 5x minus 3. So this is our polynomial. Now I need to divide this with x square minus 2. You don't worry whether it is x square or x cube. Okay, just focus on this is our dividend and this is our divisor. Now, how to get the multiplier? So the first term here is x cube, right? The first term in the polynomial divided by the first term in the divisor. So x square by x cube, you'll get x, right? X cube you can write as x square into x. So x square gets cut, so you'll get x. So the multiplier for me here is x, right? Now multiply with this. So x square into x is x cube. And then here, I don't have a x term. I directly have a constant here. So multiply with this. Minus 2 into x is minus 2x. So I cannot subtract minus 2x because I do not have any x square term. So I'll directly write it here, minus 2x. Or you can have plus 0 into x square minus 2, right? In between, you can add 0 into x. So 0 into x is 0. So you can simply have 0 here. Okay, plus 0. Or you can just leave like that also, right? Now, so if you subtract this, the signs becomes reverse. So don't consider for that because you don't have any term there. And this will become plus. So x cube gets cut. Now, this minus 3x square, we need to retain, right? And then plus 5x plus 2x. This becomes plus 7x, right? So here we have already considered the term. And what is remaining? Yeah, let's take that as well, right? So minus 3. This is what is remaining now. Now this is your polynomial. This is your divisor. So let's divide. So what is the multiplier? Minus 3x square here by x square. So you'll get x square cut. So minus 3 you will get. So x minus 3. Now multiply with this. X square into x. Sorry, with minus 3, right? With minus 3, you need to multiply. So x square into minus 3 is minus 3x square. And then minus 2 into minus 3 is plus 6. So keep that plus 6 here. And here again, just put as 0 because there is no x term there. Now you are subtracting. So this becomes plus this becomes minus, and this becomes minus. So minus 3x square plus 3x square gets cut, and then plus 7x, we can retain that, and minus 3 minus 6 is minus 9. Now, can we simplify this further? No, because here you have an x term. Here you have a square. So which is higher than the degree of this polynomial. So you cannot further simplify that. You can simplify only when the degree of the polynomial, in this case it was x square, here is also x square, in this case it is x cube and it is x square. You can simplify as long as the polynomial has a higher degree or equal degree. In earlier case it was x cube, so we can do that. X square, we can still do that. X we cannot do because your divisor is having higher degree than our polynomial, our remaining polynomial. So we cannot further reduce it. So this is your remainder. This is our quotient and this is our divisor. So now let's follow our principle of divisibility, right? So dividend is p of x, that equal to our divisor into quotient plus remainder. Let's see. What is our divisor? X square minus 2. Into what is our quotient? X minus 3. Plus our remainder, 7x minus 9. So our expectation is we should get our polynomial. So let's see. If our division is correct, we will get it. If our division is wrong, we won't get it. Okay. Let's verify. So x square into x is x cube. Then and x square minus 3 is minus 3x square. And then minus 2 into x is minus 2x. Minus 2 into minus 3 is plus 6 plus 7x minus 9. Now, x cube minus 3x square minus 2x plus 7x. Okay. So what I'll get? Plus 5x plus 6 minus 3 minus 3. So is this correct? Let's check. I don't remember the polynomial, right? So that's x cube minus 3x square plus 5x minus 3. So that is correct. So this way, whenever you get this polynomial division, what you can do is first you follow these steps, divide, reduce it until you get to the remainder, and then validate it using division into quotient plus remainder. Okay. Then you will be confident that whatever you have done is correct. In case you have done somewhere wrong, you will not get the polynomial. That is an hint for you that you need to revisit and recorrect it. Okay, so let's quickly revise this cubic polynomial division. So this is similar to any other division, like a numeric division. So we take this polynomial and the divisor, and first you need to get the multiplier. How you will get first term in the polynomial divided by first term in the divisor. So x cube by x square, so x. So multiply with x. So x square minus 2, you need to multiply with x and add the values there. X square into x is x cube. Minus 2 into x is minus 2x. As there is no x square term, you just put it 0 or just leave it blank. You just need to retain that value. So now, as you are subtracting, x cubes gets cut. That minus 3x square retain as is, and then this becomes plus 7x, and the remaining value is minus 3. You get down that value, get that value down. Now, this will be your polynomial now, that minus 3x square plus 7x minus 3. Now, this polynomial you need to divide with minus x square minus 2. Then get the multiplier, minus 3x square by x square, so minus 3. Now, x minus 3 will be your quotient. Now, multiply with that. So, you will get 7x minus 9 after you subtract. This 7x minus 9 cannot be further reduced because here there is an x term, there it is a square term. So, you cannot further simplify it. So, whenever you get a power for x which is less than the divisor's highest degree, that's where you need to leave that division. So here that will become your remainder. Then you have validated using our dividend equal to divisor into quotient plus remainder principle. And you have simplified and you have got your divisor, dividend, that is P of X. P of X, you got that. That means the division that you have done is correct. So that's how we can do this division for the polynomials. It can be fifth degree also. They can give x power 5 minus 4x power 4, blah, blah. And then you need to divide with maybe x cube. So don't get panic if it is x power 5 or x cube or x square. You just follow our principles. Take the first term from the polynomial and then the first term in the divisor, divide it, whatever is the multiplier, you put that and multiply, subtract. That will be your next polynomial. With that polynomial, if it is still higher than or equal to the divisor's degree, x square or x cube, do another iteration, same like how we did earlier, and reduce it until we get to an x term or a constant term, or a term which is higher than the degree of the, lower than the degree of the divisor. So at that time, we can stop and that will be your reminder. And how you validate? Divisor into quotient plus remainder, you should get the polynomial. Okay. So hope you are clear with this now. I think that concludes our division, dividing the polynomials using any zeros. Okay. All right.